Okay, so the first case that we want to study is 1-0. That means the reliable firm offering a warranty and the unreliable firm offering no warranty. In this case, basically we may help ourselves by highlighting some lines here and here. This tells us that we are assuming that the reliable firm is going to offer a warranty and the unreliable firm offers no warranty. Suppose this is the case, then as a consumer, if you observe a warranty, you know that the product is reliable. Okay, so that's why your P is going to be 1. You know that the product is reliable. Or if you are observing no warranty, you know the product is unreliable. So your Q would be 0. Okay, P and Q are the conditional probability for reliable company. So P will be 1 and the Q will be 0. And then is that if you are a consumer, in this case, what will you do? Okay, so I know P is 1 and I know 1 minus P is 0. In this case, if I am considering buying the product, then for buying the product, my expected utility will be 8 times 1 plus negative 1 times 0. I'm going to buy this product. Okay, I'm going to buy this product. This is of course because if I do not buy it, I simply get nothing. As an unreliable case, I will think, okay, this probability is 1, this probability is 0. If I choose buy it, my utility will be negative 7. So in this case, I will not buy it. Okay, so for the consumer, its strategy will be, if I observe a warranty, I will buy it. If I do not observe a warranty, I will not buy it. So that's after all these 3 steps, this is a strategy belief profile. And now we will need to go back to the firm's perspective to see whether there is any firm that would be willing to deviate. If you are reliable and you choose not to offer a warranty, in this case, because the consumer's strategy is that once he do not observe a warranty, he will not buy it. So in that case, your expected utility will become 0. Okay, will become 0. Compared to 8, you will not have an incentive to deviate. For the unreliable firm, it's basically the same thing. If my product is unreliable, but I offer a warranty, consumer sees a warranty, consumer will choose to buy it. In that case, my utility is negative 1 compared to my utility 0. In the other case, I have no incentive to buy it. So in this case, no firm wants to deviate, and this is an equilibrium. Okay, so now it's the other case. Is it possible that the reliable firm choose to offer no warranty and the unreliable firm choose to offer a warranty? That's the case 0-1. In this case, again, as a consumer, I can tell that the company will be either reliable or unreliable in this case. So I can update my belief because the two companies are making different decisions. And now, as a consumer, I can decide whether I want to buy it or not. In this particular case, if I observe and warranty, I know the product is bad, and my utility of buying the product will be -3. Okay, will be -3. Compared to that, 0 is better, so I will choose not to buy it. If I am here and I observe a warranty, I have no warranty, I know it is a high quality product, so I will choose to buy it because 5 is greater than 0. Okay, so that will be the consumer's strategy. If there is a warranty, do not buy it. If there is no warranty, buy it. Now, is there any company who will be willing to deviate? Yes. Consider the unreliable company. This company knows that in equilibrium, it is going to earn $0. Okay? But if he deviates to not offering a warranty, then because consumer will buy it, the unreliable firm will become making $11 as the profit. And in that case, the unreliable firm will deviate to offer no warranty. That means it is impossible for this outcome to be stable. That means this is not an equilibrium. It's impossible that these two firms making this strategy simultaneously, because the unreliable company will be willing to deviate. Okay, so in the previous two cases, the two companies are making different decisions. So in equilibrium, the consumer can tell who is who based on the observed signal. But it's also possible that these two companies make the same decision. For example, it's possible that both of them choose to offer a warranty. If this is the case, now let's do Bayesian updating. Because as a consumer, you know both companies are offering a warranty, so when you observe a warranty, you have no signal. Okay? So that's why your P is still 1/2. On the other hand, if you observe no warranty, then again in this case you have no signal. Okay, you have no signal. But here there is a technical issue that we do not say that Q is 1/2. Instead, we say Q can be any number, because when you observe no signal, okay, when you observe no signal, that somehow actually does not happen in this case, because we assume that both companies will choose to offer a warranty. So if that's the case, in fact, it's impossible for you to observe no signal. I mean, no warranty. So when we assume that the consumer observes a warranty, the consumer has nothing, has no way to do an updating, and then the posterior belief can be anything. Okay, because this is something that cannot really happen. Okay, so mathematically, of course, we can show it, but anyway, that's the intuition behind that. So in general, Q may be anything. Okay, so P is 1/2, Q may be anything. Now, the consumer's decision should be the following. If I observe a signal, I have no information, and then P is 1/2. Based on the fact that P is 1/2, 1 minus P will also be 1/2. And if I buy it 6, -3, the average is 1.5, which is larger than 0. So as a consumer, in this case, I should buy it. Okay, I should buy it. On the other hand, as a consumer, I also need to set up my strategy when there is no warranty. Okay, so the consumer need to set up the warranty, the decision. suppose the consumer is here. Okay, as we mentioned, the belief can be anything. Belief can be anything. And now, it's of course possible for the consumer to make either decision. The consumer may choose to buy it or not buy it. For example, if the consumer randomly believes that Q is 1, the consumer should buy it. If the consumer randomly believes that Q is 0, then the consumer should not buy it. Okay, there are some probabilities that the consumer should buy it, some probability that the consumer should not, because the consumer really have no information in this case. Okay, so the consumer may choose to buy it or not buy it. But the interesting thing we know is that if the consumer choose to buy it when there is no warranty, okay, then in that case, no company is going to offer a warranty. Or I am saying that if consumer choose to set A0 to B, then both companies will think, if I choose not to offer a warranty, the consumer will still buy it. Then I don't need to pay for the warranty cost, right? Then either company is going to earn $11, which is larger than its previous payoff. So it's impossible for A0 equals B as part of the equilibrium in this case. So we would say that, okay, it must be N in this case. However, even if A0 is N, the unreliable company will still deviate to offer no warranty. Think about this. Suppose the consumer decides not to buy it in this case. Then as a company, suppose I choose not to offer a warranty, my result will be $0. Okay, that will be my profit. And in the previous case, I was losing $1 of money because the consumer will buy the product anyway. So that means I have no incentive to pretend that I am reliable by offering a warranty, because that's going to hurt myself. It would be better not to do the business with the consumer. So in that case, I would simply choose no warranty. Okay? So basically that means 1-1 cannot be part of an equilibrium. That's not going to be a stable outcome. Finally, there is a possibility that no company offers a warranty. So that's 0-0. Okay, 0-0. In this case, we can update Q to be 1/2. Okay, just as the prior belief, but P can be anything. Okay, and now we can say that after the updating, P can be anything, but Q will still be 1/2. As the consumer, now I may decide whether to buy it or not buy it. If I observe no warranty, then I would think the probability is 1/2, probability is 1/2. So in this case, I average 5 and a -7. It's -1. I shouldn't buy it. So that's part N in this case. If the consumer observes a warranty, then the consumer may decide to buy it or not buy it. In this case, it really depends on how optimistic the consumer is on the product reliability. If the consumer thinks that it's greater than 1/2, okay, if the posterior is set to be greater than one third, then the consumer should choose to buy it, because with 1/3, 6 times 1/3 plus 2/3 times -3 is going to be 0. So if the probability, if P is set to be greater than 1/3, you should buy it. Or if you set the posterior to be below 1/3, you should not buy it. Okay, so there are two possibilities. either buy it or not buy it. Not buy it if P is less than 1/3, and buy it if P is greater than 1/3. Okay, now we need to decide whether each of them is possible. For the former, which means buy it. In this case, if you are a reliable firm, you will deviate to offer a warranty, because if you offer a warranty and the consumer buys it, you get 8. Previously, you simply get nothing. Okay, so that means this guy is not an equilibrium. But if consumer choose not to buy it, in this case, okay, if the consumer choose not to buy it anyway, then of course no company has an incentive to deviate. So it's still possible for this to happen. Consumers choose to not buy it anyway, and no firm offering a warranty. Okay, so now it's time to summarize everything we have. We have just discussed the 2 possible or potential pooling equilibrium and 2 possible separating equilibria. What's the definition here? In a pooling equilibrium, all the principles, all types of the principles take the same action. In a separating equilibrium, different types will take different actions. So you know 1, 0, and 0, 1. These are separating equilibrium, candidates of separating equilibriums. On the other hand, for pooling equilibrium, that means 1, 1 and 0, 0. Companies are making the same decision. If we have more than 2 types, then it's possible to have a semi-separating equilibrium. In that case, some companies are making the same decision, but not all the companies making the same decision. Okay? In this particular example, we found 2 equilibria, or more precisely, 2 sets of equilibria. There is one separating equilibrium. The good company offers warranty. The bad company offers no warranty. And the consumers buy the product when there is a warranty, and do not buy the product when there is no warranty. And also, the posterior beliefs can be correctly set. On the other hand, there is also a pooling equilibrium. Both companies choose to offer no warranty, and no consumer buys the product. And then we have a set of possible posterior belief that is consistent with the player's decision. Okay, so what does that mean? Under the separating equilibrium, one guy offers a warranty, the other guy offers no warranty, and based on that signal, the consumer can really tell the hidden reliability. That means the reliable firm is successful in signaling her reliability, and in this case, the system is somewhat efficient. The company offers a warranty, and the the firm and the consumer can see it. Okay, it's not really efficient as the complete information case, but it's more efficient than the no signaling case. Okay, and of course, this may be true because the unreliable firm find it too costly to pretend to be having a high reliability, because that cost is really too high. So that's why in this case, the unreliable firm will not deviate to offer a warranty. Unfortunately, it's still possible to have this pooling equilibrium in which no trade is established at all. Okay, so we can see that in this signaling game, due to information asymmetry, it's still possible that no trade can be accomplished, and it's still possible that no one can really buy the product. So obviously this is very inefficient, and everybody are unhappy about that. So you probably want to ask, then what's our conclusion? In such a game, there is no specific conclusion or predictions we may make based on their decisions. Okay, we cannot predict exactly what's going to happen because both are possible. Okay, both are possible, but at least we can say that it's possible for us to have a satisfactory outcome, which is the separating equilibrium. Under this separating equilibrium, we get a satisfactory outcome that the one company can successfully signal the signal. Okay, there are other situations that you really have no separating equilibrium, and all the equilibrium are pulling, and you may expect a very inefficient outcome in that case. Okay, so in general, for all kinds of signaling game, we may have multiple equilibria, and at least we hope that we may have at least one separating equilibria. That means it's somewhat possible for one of the firms or one of the principles to differentiate itself from other inefficient type of principles. Whew. So in the lecture, I will give you some more examples to help you understand this stuff. That's the end of today's lecture. Thank you.